Good morning, everybody. Really glad to be able to meet with you all and speak to you all today for the workshop. I really appreciate uh, this community gathering together. Um, and I um, introduce myself. My name is Sean Breeding. I am the Moon to Mars Environments Lead. I support SE&I. I'm stationed at Marshall, um, or work at Marshall. Um, but I do support the Moon to Mars. It's all environments, so it is natural. I support natural and induced environments. And so today I'm here speaking with regard to Plume-Surface interaction, which is one of our considered induced environments. And really glad to see presentations on contributing to the development of that study of that newly forming uh, techniques for evaluating. Next slide, please. So I thought I would go over uh, the overview of a PSI TIM that we had back in May of this year, because I think it gives a really good outline uh, of the overarching intersection for Moon to Mars with the science community, the modeling community, payloads, landers, the whole architecture and what we're struggling with. So the TIM that we had in May, you can see a lot of your panelists and contributors were a part of that. You're going to see a lot of these topics covered today here. Uh, the main priority, and my slides are quite wordy, so I'm going to just speak over them and let you guys kind of digest them, and you can ask me questions later so that we can stay within our allotted time. But this TIM was to uh, get better understanding of Plume-Surface interaction development. We wanted to get the modeling community, the science community, and the ground uh, testing community and flight data. We also wanted to pull in the planning community. Surface planning uh, has to develop concept of operations. They have to map out milestones for given missions. That's Artemis 3, 4, 5, and further. And so this TIM was the first attempt to bring all of those entities together and look at where we are with Plume-Surface interaction and have these discussions. And I thought it was a very good initial interaction. And so let's go to the next slide. Some of the areas that we discussed that I think are also going to be discussed somewhat today is PSI modeling and validation, the ground testing program. You'll hear presentations today on lander modeling, architecture modeling discussions we also had. We also always like to include our natural environments discussion to make sure that modelers are aware of where their uh, properties and assumptions should be derived upon when they're building those models. And then we also talked about how we plan to publish and maintain induced environments for surface elements within the Moon to Mars program. We also had discussions on science aspects. The surface planning community was there. For gathering data, we talked about CLIPS payloads, sensors, and missions. Uh, we began to have initial discussions of how we handle ejecta from a Moon to Mars or a surface elements perspective using MMOD assessments. And then we also had a presentation from LRO about their data collection methods and their analysis methods. And then we finish it up with flight environment data, looking ahead at future CLIPS programs, uncrewed demos, and Artemis missions that we can pull from to gather data to help um, correlate models and such. All right, next slide. And we also looked at future architecture. I'm not going to talk this word slide. This basically was a grading that we gave upon ourselves on the outcome. A lot of this I'll skim it real quick and see if it's useful. I think you're going to hear from Scalps today or tomorrow. We're going to have some clips discussions. The Artemis flight data gathering is very key for what we're trying to achieve here. Basically, two specific areas are newly forming, and so the verification methods for those areas are not quite mapped out as well as the normal thermal and loads verification methods. And so the modeling greatly assists us in being able to plan and look ahead at what we may see in each of these missions. And the architecture that we have for these missions is also quite useful in that Artemis 3 does not have as many surface assets, so it's a more simplistic mission that has less players in Plume-Surface interaction. We hope that we will make some qualitative, quantitative observations for both PSI and dust on that mission. And as we move forward, we typically, for these two areas, will use a risk system to try to mitigate the risk associated with these newly forming areas and map out uh, 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 data gathering approaches and data gathering opportunities. Um, and so you're seeing some of that discussion that we had for the first time as a group and how well we did on that discussion. Next slide. Some new developments since the TIM that I thought I would denote are some interactions that we had at the Lunar Surface Science Workshop. Uh, we have an extra vehicular activity human surface mobility program, EHP, induced environments document that is being developed and will hopefully be our source of ejecta and dust induced environments for surface assets. So all of the work that you guys are doing, the modeling, the testing, the validation, hopefully is going to pay forward and allow us to publish ejecta and dust environments for payloads and surface assets. And they'll be able to utilize that document for that purpose. I think you're going to get a presentation on the PSI ground test and its status and where it's at. There's also been within the SENI community, there's been some activities with regard to developing this new ejecta induced environment. We're collaborating between EHP and the PSI entities within HLS to develop that. And it's kind of based upon a method that was developed by the Disney community, where they plan to incorporate natural lunar surface ejecta in an upcoming revision of the Disney specification. And Disney, for those who are unclear, that is the Artemis level natural environments document that is a reference for all programs within Artemis. And so that will use, JSC has an HVIT, a hypervelocity impact technology group that do micrometeoroid and orbital debris risk assessments. And that process will include using that method for ejecta only. There's a subtask that we're working for dust, but different workshop. Let's see what else. And we are here today at the workshop. Greatly appreciate that. There are several proposals also out there that are developing PSI sensor packages. I think Scalps will give you a better overview of that. Robert Maddox will be covering that as one of the presentations. Next slide. And that's all I've got. I tried to be brief, and I know I went quickly, but it's a high-level overview. The attempt was to show you how your work integrates up into the architecture and where we do need your help in defining these environments, because they will impact surface entities and science payloads and the positioning of those payloads and the support of those payloads will greatly depend on the efforts that you guys are doing within your specialized areas. So I really appreciate your support. I think I'll finish a little early, Addie.
No problem. I can ask a question then. It's perfect.
Okay.
Thanks so much for this overview. I think it's helpful. One of the things we have this morning is sort of this overview of from sort of the different perspectives within NASA. And I think one of the questions a lot of us who are researchers have is what, other than like publishing our papers, obviously, what are the best ways that the sort of results of our work, external to NASA, for instance, can be translated into design specifications and guidance that you all then use?
Yeah, it's an evolving, newly developed area. Typically, what I foresee is that we will need the best modeling efforts that you have that are based upon gathering that flight data and correlating those models to give us the best estimates on ejecta and dust, because you guys will begin to participate in the dust transport aspect of PSI also. It's already um, in discussion. I guess the way I put it is PSI is the first transport mechanism that we should be able to get some observations on for Artemis 3 for that reason. But the publishing, what I've seen in the past is there's limited ability to distribute some PSI modeling due to uh, propulsion commercial developments that are considered proprietary. So I struggle with the distribution. Typically, I've seen that they are kind of held within pockets of programs. So being able to um, filter proprietary data would give you a better chance of going to conferences and presenting, and so today is one such option um, to begin to get the word out. The dust community has participation in LSIC. Are you guys part of LSIC? So, and I'm trying to remember Lunar Surface. I'll type
Lunar
back
Surface
in.
Innovation Consortium.
Yeah. So LSIC is a very good opportunity for you to get some visibility, to get some interaction with uh, communities that are also struggling with the same um, issues with regard to PSI and dust mitigation. So LSIC is one venue. That's really all I could offer this morning, Addie.
Okay,
And maybe Ashley um, might have a better answer than I do this morning.
great. Okay, yeah, thank you.
Thank you.
Wesley, did you have anything?
No, I was just looking in at some of the questions that were coming in on the Q&A tool. Looks like
Yeah,
there
I
was a
typed
question.
mine.
Oh, sorry.
I put
No,
mine
I did
in
not
there
have any,
just
but if you wanted, it looks like one of them is kind of similar already. So we can try to put that in here, but there was, how can scientists or technologists best convey the results or issues to inform Disney,
Yeah,
etc.
I just typed it in to capture it in the
Oh,
Q&A.
I'm sorry. Okay. But yeah, the other one, are there currently any CLIPS missions, that are flying with PSI, Plume-Surface Interaction payloads? Was the other question here.
And I think that one will be addressed by the Scalps presentation,
Yeah.
to some degree. So I don't want to
Yeah, so we actually
steal
will
any
have
thunder.
Yeah, we have the Scalps presentation as well as the Heimdall presentation. And then I think Ryan Watkins is going to cover a bunch of the CLIPS missions.
Yeah. And I guess one clarification here, I think we had mentioned is Disney DSNE is an acronym,
Yeah.
and it stands for the Design Specification for Lunar or for Natural Environments. And so that's a public facing document that defines environments for spaceflight programs. can put a little more information about that in chat.
Yeah, sorry about that, Wesley.
No, that's all right.
Dropped the ball on that
All
one.
right. Thanks.